question is, a solution of NiNO3 twice is electrolyzed between platinum electrodes using 0.1 Faraday electricity. How many moles of Ni will be deposited at cathode? Okay. So the reaction that takes place at cathode in the electrolysis of NiNO3 twice is that the Ni plus 2 ions gain 2 electrons and lead to the formation of nickel, right? So as you can see, 2 electrons are involved here, which means that 2 Faraday, on passing 2 Faraday of electricity, right? On passing 2 Faraday of electricity, 1 mole of nickel is deposited. So you have to find how many moles of nickel will be deposited at cathode if we are using 0.1 Faraday electricity. Okay, so 1 Faraday electricity will lead to the formation of 1 by 2 mole of Ni, right? And 0.1 Faraday of electricity will lead to the formation of 1 by 2 into 0.1, which will actually be equal to 0.05 moles of nickel, right? So 0.05 moles of nickel will be deposited when 0.1 Faraday of electricity is passed through it, right? So that's the correct answer for the question.
Hello, the question says that calculate the standard cell potential in volt of the cell in which following reaction take place. Fe2 plus aqueous plus Ag plus aqueous gives Fe3 plus aqueous plus Ag solid. So we have given that E0 for Ag plus converted as Ag is equal to X volt. E0 for Fe2 plus converted as Fe is equal to Y volt. E0 for Fe3 plus converted as Fe is Z volt. And we have 4 options. So let's solve this question. So firstly, our reaction is Fe2 plus aqueous plus Ag plus aqueous gives Fe3 plus aqueous and Ag solid. So Fe2 plus is converted as Fe3 plus. So here oxidation take place. So oxidation take place at cathode. And here Ag plus is converted as Ag solid. Here reduction is taking place, so this reaction will take place at anode. So E naught for this reaction is equal to E naught for Fe2 plus converted as Fe3 plus E naught for Ag plus converted as Ag. So in the question we have given that E naught for Ag plus converted as Ag is equal to X volt and E naught for Fe2 plus converted as Fe is equal to Y volt and E naught for Fe3 plus converted as Fe is equal to Z volt. So now we have E naught for Ag plus converted as Ag and we need to find E naught for Fe2 plus converted as Fe3 plus. So for the reaction Fe solid gives Fe3 plus 3 electron, E naught value will be minus Z volt because E naught value of Fe3 plus converted as Fe is equal to Z. So E naught value of Fe converted as Fe3 plus will be minus of Z. And for the reaction Fe2 plus aqueous, this is also aqueous, plus 2 electron gives Fe solid. E naught value is equal to Y volt. So when we add them, we will get Fe2 plus aqueous gives Fe3 plus electron. So let's say E naught value for this reaction will be m volt. So for E naught value of our final reaction, we can't add E naught value of first reaction plus E naught value of two reaction because E naught is an intensive property and we can only add or subtract extensive properties. So therefore we will use delta G. So therefore delta G3 naught is equal to delta G1 naught plus delta G2 naught. Delta G3 naught is equal to minus 1 Fm delta G1 naught is equal to minus 3F minus Z plus delta G2 is equal to 2Fy. So now we can cut F with F. So from here M is equal to 2Y minus 3Z. So now we got E naught value for Fe2 plus converted as Fe3 plus is equal to 2Y minus 3Z volt. So therefore E naught of the reaction is equal to E naught for Fe2 plus gives Fe3 plus E naught value of Ag plus gives Ag. So E naught value of Fe2 plus converted as Fe3 plus is 2Y minus 3Z, and E naught value of Az plus converted as Ag is X. So our final answer will be X plus 2Y minus 3Z. So now let's match our option. So our third option will be correct answer. Thank you.
Hello. So question says that here are the given data and find out the strongest oxidizing agent, right? So we have to find out which of the following is the strongest oxidizing agent, right? So let's try to solve this question. So before doing this question, we have to understand the basic definition, right? So what do you mean by reduction, right? So if I'm talking about the reduction, right? So if I'm talking about the reduction, so reduction is a process in which there is a decrease in oxidation number, right? So there is a decrease in oxidation number, right? So whenever there is a decrease in oxidation number, whenever there is a decrease in oxidation number, so you can understand that there is a reduction process taking place over there, right? So and when there is a increase in oxidation number, right? So there is a when there is an increase in oxidation number, right? So this is oxidation. So in this oxidation, the increase in oxidation number takes place, right? So increase in oxidation number, right? So I can write here as increase in oxidation number takes place, right? So these are the basic definition for reduction and oxidation, right? So now come to the point, what what do you mean by oxidizing agent, right? So I can write here, what do you mean by oxidizing agent, right? So oxidizing agent, right? So this is oxidizing agent, right? So this is oxidizing agent. So what do you mean by understand this, right? Oxidizing agents are those agents which carry out the oxidation of other, right? So I can write here as which carry out the oxidation of others, right? Oxidation others, other species, right? So which carry out the oxidation of other species, right? Number 1 point, and number 2 point, they reduced itself, right? And itself, I can write here clearly, and itself they reduced, right? They reduced, right? So they are the 2 points of the oxidizing agent, right? So we have to find out the species which has a high value reduction potential, right? Because oxidizing agent are reduced, right? So itself, right? So I can say that the species which has a higher value of reduction potential, or you can say high value of for reduction potential is will be the strongest oxidizing agent, right? So let's try to find out, right? So if I talk about the data, so in the data it is given that, if I talk about the data, it is given that E naught, right? So if E naught for O2 to H2O, right? So O2 to H2O, right? So for this value, the data is plus 1.23, right? So plus 1.23 volt, right? So in this data, we can say this, here the oxidation number, or the oxidation state is 0, right? And here the oxidation state is -2, right? So you can see this clearly, the decrease in oxidation number takes place, right? So here I can say that reduction is taking place from here to here, right? So this is the value of reduction potential, right? So this is the value of reduction potential, right? So now if I move further, so I will get S2 to negative, right? So S2 to negative, right? So E naught S2 O8 to negative to SO4 SO4 to negative, right? So here the value is given as plus 2.05 volt, right? So this is the value of, right, oxidation or reduction potential, because here we can see that the sulfur has oxidation number, here the sulfur has the oxidation number +7, right? So sulfur has the oxidation number +7, and here it is +6, right? So here it is +6, right? So you can see that the decrease in oxidation number, so which means reduction is taking place. That means this species is also act as an oxidizing agent, right? So now if I talk about the another data, the another data is like this. Another data is like this. E naught of the E naught of Br2 to Br negative, right? So Br2 Br negative, right? So it is a, you can say bromine, it is a liquid state, so you can say that has a zero oxidation state, right? So it has a oxidation number is 0, right? So it is you can say it converting into -1, right? So there is a decrease in oxidation number, right? So for this the value is given as for this the value is given as plus 1.0 volt, right? For this the value is given as plus 1.0 volt, 1.09 volt, right? And for the one and last thing is Au3 positive to Au3 positive to Au, right? So it is 1.4 volt, right? So for this Au3 positive to Au, right? So the value is 1.4 volt. All the values are positive value, right? So here is also 3 to 0. That means decrease in oxidation number. So reduction taking place, right? So from this data, I can say that all the data have a reduction potential value, right? So these are the value of reduction potential value, right? So we have to find out that in which of the following species is the strong oxidizing agent, right? So we know that higher the value of reduction potential, higher will be the oxidizing agent, right? So let's see this. So in this data, we know that 2.05, right? So in this data, we can say that 2.05 will be the highest data, right? So for reduction potential, right? So in this way, I can say that S2O negative, right, is the strongest oxidizing agent, which is converting into SO42 negative, right? So I can say this: the S2O8 negative, S2O82 negative is the strongest oxidizing agent, right? So it is the strongest oxidizing agent, right? So in this way, I can say this: the our correct answer will be, in this way, I can say this: our correct answer will be C answer, right? So C answer will be the correct answer, right? So if I talk about the, you can say least oxidizing agent, or you can say the weakest oxidizing agent, the weakest oxidizing agent will be the 1.09, right? So it is 1.09. So it will be bromine, right? So it will be bromine, right? So if I, but in the question we have asked the stronger oxidizing agent. So our correct answer will be S282 negative, which is the correct answer, right? So the rest of the answer will be the wrong answer, right? So in this way, I can say that the correct answer will be C, that has a S2O82 negative, which is strong oxidizing agent, right? So hope this answered your question. So thank you.